Split screen new space. That looks good. Cool. And I should also send this to Calgary. No, I thought a Raspberry Pi would be a little bit overkill. What are we? We're Calgary, 2nd of October, right? Okay. Let me know when you can hear me. Guess that means I gotta open Slack here. Not email. Joel wrote what?
I asked him a question about JavaScript object, and he's like, okay, short answer, Joel, just wrote Joel words. And then I had a half-hour conversation with him about 20 minutes with Dawn, and then about an hour and a half with Jeremy.
About what?
Okay, so you know about map.
Why? Yeah, why were you using why? Why map?
Because a Stack Overflow answers, that's how you represent game state.
You could represent state however you want in a program. Like you could just use one string or one integer or yeah, I guess you could just create. No one uses. Uh huh.
And so they don't care if it's similar looking or if it's not the same structure. Then it goes undefined. I can't find it.
Yeah, so maps suck. So use like objects.
Use an object.
Yeah.
So here ride that as reality.
Oh, okay. Oh, where the hell do I go with this? Web, no, October, Calgary. There we are. Sweet. Getting it set up. All right, we'll just wait for Calgary. Good to go. All right. How's everyone doing? How's this week? Apart from trying to represent game state with maps. I asked a question, and you didn't know what I asked because you were talking. Now you have to answer that question with no context. Go ahead. At Sam, it looks like you're wearing a sweater without a shirt underneath. Huh. I will neither confirm or deny those, like a true Australian. That's what you get for wearing skin-toned clothing. What was my question? I don't know. I just said, how's it going? How has this week been? How's React? Give me something, you know? Yeah, it's awesome. What else? It sucks. WebSockets are cool. This was confusing. What the hell is bind for? Oh, yeah, I don't know. I didn't stick around for presentations. Oh yeah, that was the role-playing game about climate change. BajoIsland.com. Okay. Huh? They did because everyone. It takes like 5 minutes to buy a domain and point it to your Heroku site, and then you look way more professional. And no one believed me until in front of them I was just like, screw it, give me your credit card, and did it in 5 minutes. It's like, that's. Yeah, but Heroku still goes to sleep even if you buy a domain. Anyway, just something to keep in mind when you're working on things. I guess I need a web browser. All right. Okay, what are we talking about today? Before I derail too much. You guys are awful today. What are we talking about today? Oh, come on, no one knows? The what? Prototypes. Yeah, exactly. What are prototypes? Let's see, am I going to put that there and regret it? No, I think that's good. Okay. What are prototypes? Prototypes. Someone tell me something. They are everything. Yeah, no, not really. What are prototypes? Tell me anything about prototypes. Has anyone started on today's assignments yet? Couple people? What are prototypes? That's accurate. Prototypes are objects. Anything else? No? All right, let's learn about prototypes then, I guess. So, as we've seen in bootcamp, like week 1, day 3, you learn about objects, right? Where we were like, I don't know, here's an object and it's some key value pairs, right? Something like that. Yeah, you learn how to use objects. Then around week 5, we taught you about classes. Kind of look like this, I guess. Whatever. Everyone comfortable using classes in JavaScript right now? There's also this other way of creating objects called Constructor Functions, which kind of look like this. So I can just create an object out of the blue. I could first create a class and instantiate a new object from that, or I can use these constructor functions. These are all valid ways of doing object-oriented programming in JavaScript. Does anyone know which way is the correct way, which way we should be doing object-oriented programming in JavaScript? Should we just be creating object literals on the fly? I guess I should have an equal sign there. Should we be using classes, or should we be using constructor functions? I got a shrug. I kind of like that answer. What's the answer to that question? Anyone got a theory? Got a guess? Getting some bad feedback on the mic. I don't know anything about mics. If I move it away, does that help? I guess I should say some words and stuff and things. Yeah. Anyone want to guess? Many. If I have many objects. Maybe.
I think there's a use case for some.
There's definitely a use case for each one. Probably the most important thing I would say is what is everyone else on your team doing? What does the rest of your code look like? So you don't want to use a class, then a constructor function, then object literals. But really, there's no correct way of doing object-oriented programming in JavaScript. A real glass half empty statement. So whether you're using classes for everything, like React does, whether you're using constructor functions for everything, like you'll see in code written up until like 2 years ago, or whether you're just creating object literals and you never use classes, never use constructor functions, you're not really doing it right or wrong, you're just doing it that way. And as long as you're consistent, that's good. Which way do you think is the easiest way of programming? Using classes, constructor functions, or the thing we learned in week 1, day 3? Yeah, most likely the thing we learned in week 1 to 3. Which way do you think is the most powerful way of programming? Where can you really do the most and control, have the most control? Third one? First one. So these ways, this is just an abstraction around this, and this is just an abstraction around this. And we'll see how all of that works. So I'm guessing, Cal, agree that the microphone's a little bit better now that I moved it away, since I didn't get any more feedback. Okay, so let's take a look at how in-depth, how object literals work, and then we'll use that to kind of see how constructor functions work, and I'm pretty sure everyone already gets how classes work at some level. So we will try probably avoid any topics with that. Other than, I will say classes don't exist in JavaScript. This is not a real thing. So keep that in mind. Yeah, classes do not exist in JavaScript. Like drop that on you before we start moving. Okay, so that's, I don't know, objects.js. Who's got an object that we could create, a noun of sorts? A thing.
Train.
Let train equal, what does a train have? Cars. What's the value? Array of cars. I don't know, there's like a yellow car and like a red car and like a shiny car.
I think the caboose is something.
That's like my knowledge of cars right there.
That's perfect.
Yes.
And someone who used to work with the
Bar car. Bar car?
Yeah.
What's a bar car? What? I don't know what a caboose is. Car with circus animals from the beginning of the last crusade. A train car with a bar in it. Oh, okay. Yeah, that's sure. Why not? Car with circus animals. All right. What else does a train have? How do you spell it?
C-A-B-O-O-S-E-Y.
Caboose. True. Sweet. All right.
Int, obviously. There can be more than one. There'll be an integer.
Let's 2 engines. What's the average number? I don't know.
Length. Well, length is construct length.
Sure. What does a train do?
Destination.
Choo choo. Camel case. What does choo choo do? Console log emissions. Boom. That's a good looking train. Annie and Clara. What? Those are trains?
Train car with a bar in it.
Wow. All right. What's another thing? Let's go. We got a train. What else do we have? Something else. Completely unrelated to trains. Postal workers? See, maybe Adam's got something. Postal workers. We have a method that says work and it just returns, no, not right now. Okay, let postal worker, worker, I don't know, what does a postal worker have? A name? What's the postal worker's name? Andy. Deliver mail, be a function that like, not now, I'm striking. What else does a postal worker? I don't know. Is that good enough for a postal worker? Maybe like mail. And you think it's a boolean, but actually it's a string because you want to be able to represent maybe. Okay, so we got a postal worker and a train. All right, this is all. I'm pretty sure still week 1, day 3 stuff. So that's good. Nice review time. So if I have a train and I wanted to console log the train's engines, how would I do that? Train.engine, come on, just making sure you're alive this morning. And if I wanted to have the train go choo-choo, how would I do that? Everyone together now. Train.choo-choo. Did this to yourselves. Okay, and if I wanted the postal worker to deliver mail, okay, all of that should work. So we should get like 2 emissions, not now I'm striking. Let's see. Did I put this in it? Yeah, I did. All right, node objects. Cool. Right? So are there any questions about what we've done here? There are objects, they have key value pairs, properties. The values can be functions, in which case we'll call them methods. And we can access them and invoke methods just like this. Any questions about that or anything that someone doesn't understand about this? Okay, great. This is the foundation of everything else we're going to talk about today. So, Thomas the Tank Engine. Let's say I wanted the train to be able to deliver mail, right? The postal workers just aren't cutting it right now, so let's have the train just deliver the mail. What's going to happen if I ask the train to deliver mail? Deliver mail is an undefined function. I mean, it's a function. It just exists over here. Train.deliver mail is not a function. Type error. Well, that sucks. What if I wanted the postal worker to choo-choo? What's going to happen? Damn it. Choo-choo is not a function. Why is choo-choo not a function? Yeah, I mean, choo-choo is a function on train, but postal worker does not have choo-choo. I can see everything that postal worker has. Everything. And definitely choo-choo is not in there. So, do we want the postal worker to choo-choo or the train to deliver mail? We need mail. We need mail, damn it. Or do we need the postal workers to start choo-chooing? Okay, so let's try and answer this question. How does property lookup work in JavaScript? How does property lookup work in JavaScript? So, as we've seen here, if we have a property on an object and we access that property, sweet, no big deal. JavaScript just goes to that object, says, hey, do you have a property engine in this case? You do? Sweet, what's the value? All right, I'm going to console log in. That's the end. Now, what happens if JavaScript asks an object if it has a property and that object does not have that property? Well, what happened when we did it here? Postal worker choo-choo. Trying to access a property that doesn't exist on an object. What happened? It threw an error. You're right, it did throw an error. So at some point between JavaScript looking on the object for the property choo-choo, the property that does not exist, and forgotten how I started this sentence. But at some point, our application may crash if it cannot find the property, right? Postal worker cannot choo-choo. So let's see. But postal worker dot choo-choo. Just leave that in there. Make sure it's still crashing. Cool. Okay. So it might be. Your first thought might be, anyway, that you try to access a property on an object. If it exists, cool, we just access the value. And if it doesn't, then maybe we throw an error. Maybe JavaScript throws an error. But as one person mentioned, JavaScript will actually look at that object's prototype. Now, has anyone done enough reading, or can anyone tell me what that means? What does it mean that JavaScript is going to look at that object's prototype? So the answer was it's basically doing what extend did. No, extend is basically doing what prototypes does. Okay, so every object in JavaScript, let's write this. Every object in JavaScript has a prototype. I'm writing it like this because when I'm talking about the idea of a prototype, I'm going to write it like this. And when I'm talking about direct syntax that is actually valid JavaScript, I'll write it a little bit differently. But every object in JavaScript has a prototype that we can access using __proto, which some people have probably seen, right? Has anyone not seen this ever in their life, __proto? One person, two people, yeah, okay. So it comes up, like sometimes you'll see it in debugger messages, sometimes instructors will just type it. But you can access an object's prototype using __proto. So every object in JavaScript has a prototype that we can access using this property. So that means that I could create a brand new object in JavaScript, and I can access its prototype. What's that? It's another object. So what does that mean? Can I access that object's prototype? So every object in JavaScript, every single one, I just created this out of the blue, no big deal, has a prototype that we can access using __proto. The prototype has a prototype, which is another object. There we go. The prototype itself is another object. So obviously, we could access the prototype of that object until you get to the very end of the chain, which is null. That's how you know you're at the end. There's no more looking can be done. Okay. So JavaScript objects are linked to other objects through this prototype thing. Every object has a prototype that is another object that has a prototype that is another object until you get to null. It's a very linear thing. So how JavaScript looks up properties is that it asks the current object. So in this case, let's look at postal worker.choo-choo. It asks postal worker, hey, can you choo-choo? Postal worker says, no, obviously not. I don't have a choo-choo method. But why don't you go and ask my prototype? So then JavaScript will go and look at postal workers prototype, which is another object, and it'll say, hey, do you have the method choo-choo? And that object might say yes or no. If it says yes, then we just use that choo-choo instance. If it says no, then we continue on to the next one until we get to null, at which case it will crash because it just can't find anything on null. So any questions so far? All right. So with that in mind, and we'll go into way more depth as the lecture goes on, but with that in mind, how could we make it so that postal worker can in fact choo-choo? Without adding the method to postal worker, of course. Wait, what? We could add choo-choo to its prototype. What else could we do? What if we made postal worker's prototype the train? Then JavaScript goes to postal worker, hey, can you choo-choo? No, I cannot, but check with my prototype. Oh, your prototype's train. Train, can you choo-choo? Absolutely. All right, let's just use that choo-choo then. So how can I make postal worker's prototype train? Someone hasn't said anything. How can I make postal worker's prototype train?
Object.create.
You've said stuff already. Given what I've written, how could I very simply set postal worker's prototype to be train? That was pretty easy. So now postal worker's prototype is the train. So does that mean postal worker can now choo-choo? Shall we find out? Okay. How do I get out of this? There we go. Node objects emissions. That was kind of underwhelming, I guess, as like as a thing. But yeah, the postal worker can now choo-choo, and if we get rid of all of this other stuff, so there's no more noise. There we go. The postal worker is now choo-chooing. Isn't that nice? Isn't that nice? So, how does property lookup work in JavaScript? Well, JavaScript asks an object if it has a property. If it doesn't, it will check with that object's prototype, which is another object. So kind of everything just starts over again. Hey, do you have this property? And if you don't, I'm just going to check with your prototype until you get to null. Any questions? Subsidized retraining programs for postal workers to become train engineers. No, just to become trains, not train engineers. And Andy, the postal worker, is going to become a train. Reach for the stars.
I got CHEW.
Oh, you've got CHEW. You can choo-choo. Oh, geez. Okay. So one other thing I want to emphasize here is that it's just objects linked to other objects. That's all the prototype thing is. Prototype. It's just objects linked to other objects. Nothing more than that. Just link up objects however we want. So postal workers prototype can be train, which is just another object. Train's prototype is just another object, and so on. So it's kind of like, okay, so I'm an instructor, and what would something you'd ask me? And everyone goes silent. Sam, we wouldn't ask you anything. What is something you might ask me?
Should I use a map?
Should, all right, yeah. So you might ask me, hey, Sam, should I use a map? And I'll be like, you know what? I actually have no idea. So let me go and ask a different instructor. Hey, Joel, can you answer this question? Joel might be like, you know what? Actually, I can't answer that question. Let me go get Jeremy. Jeremy, can you answer that question? And Jeremy can't answer it, so then you end up at null and it crashes. But it's that's what happened last night. But that's generally what the prototype chain is, just this linear linking of objects with other objects. So there's not this hierarchy. It's just This object can't do it, so let's ask its prototype, and so on. Keep going along this prototype chain. So we've seen that if I create an object, it has a prototype. Obj underscore underscore proto. Immediately, if I create an empty object, it already has a prototype. What do you think its prototype is? What do you think by default, when I create an object, what do you think that object's prototype is? The prototypical object. Any guesses? What do you think this is? Got a guess, Remy? Let's see, Calgary, any guesses? Nothing? What is the default object's prototype? Or what is the object's default prototype? Its own object. Pardon? Like it's its own prototype. That'd be kind of like the object's prototype is itself by default. That'd be kind of cool. Like Sam, do you know about map? No, I don't. But wait, let me ask my prototype. Hey Sam, do you know about map? No, but let me ask my prototype. I love that as a good guess. You cannot have prototype cycles, and that would be a cycle. So an object cannot be its own prototype, but also Andy could not be my prototype, and then I be his. Or yeah, JavaScript will just lose its mind and stop.
Like the thing that has all the methods you can call.
Ooh, it's like that thing that has all those methods that you can call but you didn't know you can call. What is one of those things? Dot length is not a thing. That's one of those things. Like toString. Okay, so I have this object, var obj. It has no properties, 0 key value pairs. I've created an empty object. However, for some reason, I can call obj.toString. Ooh, where did that come from? It didn't exist here, right? It must be in its prototype, because JavaScript will ask object, hey, do you have a toString? Object will say, no, but you can ask my prototype. Hey, prototype, do you have toString? Well, it must do, otherwise it would just crash. So what is the object that has these default, the toString? What's another one? I don't know, toString's like the most popular. I just want to make sure length isn't one. Yeah, length is not one. Undefined. So, obj.keys. toInt. Just guessing stuff now. Does anyone know which object has the toString? Object function. Almost. Has anyone heard of object.prototype? Object.prototype. We'll see exactly what this is, why it's named like this later on when we get into the constructor functions. But right now, just know that anytime you create an object, by default, its prototype is this object.prototype object. Must be an object because all prototypes have to be an object. And it has certain properties on it, like toString, or value of, or dot underscore underscore proto. Why do you think I can access dot underscore underscore proto of object, of obj? Because it exists on its prototype. Let's see, what else? Is there a fun one in here? Has own property is prototype of toSource to local string. Wow. To local string. I wonder what that does. Oh, it literally just calls toString. Watch on watch value of, what does value of do? Returns the primitive value of the specified object. Dot value of. Oh, that makes sense. Type of is an operator, different thing, different JavaScript thing. Okay, so let's just verify this. If I go obj dot underscore underscore proto underscore underscore equals object dot prototype, you can see they are the same thing. So by default, an object's prototype will be this object dot prototype. And what is object dot prototype's prototype? Null. That's the end of the line. That's it. If it's not there, then your app's just going to crash. Well, if you're trying to invoke a method. If you try and access a property, you're just going to get undefined. Okay, any questions?
Yeah, it's like, that makes sense, but then in the NPM doc, it said that proto was, proto was part of the object prototype.
Yeah, underscore underscore proto is a property on object dot prototype.
So then, why would it be null?
Because that tries to access the current object's prototype, like square bracket prototype. So if it has one, great, and if it doesn't, then it will be null. So there's another thing to think about. Here I've got my postal worker. If my postal worker tries to deliver mail, let's just make this a little bit more fun. We'll get the postal worker's name plus a not now I'm working. Right? Everyone comfortable with this? Yeah. So not only are we console logging just a random string, we're also grabbing one of the properties out of this object. And we'll do the same up here. So let's say when we choo-choo, we're also going to log out this dot mail, because we're just writing weird code right now. So if I was to call train.choo-choo, what would get logged out? Undefined emissions. If I call postal worker.deliver mail, what's going to get logged out? Andy, not now, I'm striking. Striking. What happens now? Postal worker's prototype is train. What happens if I call postal worker.choo-choo? Undefined emissions? Ooh, yeah, how does this work in this case, right? If the postal worker is the one choo-chooing, is this going to refer to the postal worker, or is it going to refer to the train?
It's the thing that calls the function.
And what if train has mail? Okay, so everyone think about what's going to happen. We're going to run it, and it's only going to choo-choo, so we'll see exactly what happens. But yeah, we're going to call postal worker.choo-choo. What is going to get logged out? Maybe.
Can we do a vote?
I don't know what we're voting for. We didn't really come up with...
Emissions or who emoji emissions?
Okay, so we've got, undefined emissions. Anyone raise your hand? Poop emoji emissions. Okay, we got 3. Maybe emissions. Oh, most people for maybe emissions. Ooh. All right, let's see. Maybe emissions. So, we say postal worker choo-choo. JavaScript goes to postal worker. Hey, can you choo-choo? No, I can't. But why don't you check with my prototype? Hey, train, can you choo-choo? Absolutely. What does train do? Well, it says this.mail. So JavaScript starts all over again. Hey, postal worker, do you have mail? Yes, I do. Cool, then we stop there. But let's say postal worker didn't have mail. JavaScript would ask postal worker, hey, do you have mail? No, I don't. Then it will go to the train, hey, do you have mail? Yes, I do, and yeah. It would go like that. So the this inside the method always refers to the object on which the method was called upon. So here, this will refer to postal worker because it's the thing to the left of the dot. And that means that it's just looking up the property on the postal worker. So JavaScript just goes back and checks, hey, do you have it? If you don't, I'll check with your prototype, and if it doesn't, I'll check with its prototype, and it goes on. So so yeah. If poster work has mail, we'll use that one. If it doesn't, then we can expect this mail to get called. That, I was not expecting that. I didn't, that just, what a happy coincidence. Wow. It's not often that just happens, you know? Good, good. We're learning about prototypes. Okay. So, when we call .proto on an object, although the method exists on object.prototype, it's going to look within the current object it was called on to see what that current object's prototype is. Okay, any questions before we move on a bit? Yo. If you wanted to grab the prototypes version of, so in this case you wanted it to actually be the trains mail, not postal workers mail, you have many, many options, none of which are in the scope of this lecture. But you know, you could use bind, apply, you could literally call the trains thing in here, you could say this .proto, I don't know. All of them seem a little hacky. Usually that's not the behavior you want. Usually if you're referring to this, like the reason we use this is so it can be dynamic. Yeah. Okay. Any other questions? Nope. All right. So let's start looking at a different object, and we're going to create this a little bit differently. We're going to create it within a function so that we can create many of them. So I don't know. Has anyone got a good idea for an object to make? Starting over. No one's got a good noun? A bad noun? A mediocre noun? I love how no one says anything, and then at the exact same moment, boom. Lighthouse employees sounds kind of dull. Pancakes, on the other hand. You said pancakes, right? Pancakes, on the other hand. Pancakes.js. Okay, so in this case, looking back at the train and the postal worker, I'm creating one object at a time, right? But what if I wanted to create multiple trains or multiple postal workers? What would I do? I'd have to like literally write out postal worker 1, postal worker 2, and then I'd have to define all the keys and values every single time. You know, what if I wanted to create multiple trains, but I actually wanted some default values, like default engines to 2 and caboose to true? How would I do this with my object literals? Without, you know, literally just copying and pasting this over and over again. Usually the way to avoid duplication is to use a function, and I think that's a not bad solution in this case. So instead of just creating the object literals and the outermost scope, I think we'll create it in a function and be able to call that function multiple times to create multiple instances of pancakes in this case. So I'm going to create a function, I'm going to call it new pancake, and we'll create a pancake. I don't know why I switch so seamlessly between ES5 and ES6, just no good reason. Maybe I'll just use const. Why not? Why not? What does a pancake have? What are the toppings of a pancake? No one wants input on this? Calgary, what's a pancake topping? What? Wow. Wow, this is all that goes on pancakes? Yeah, okay, we'll see. Cheese whiz. Cool. Thank you. Adam? Adam is now a topping also because I accidentally copied and pasted too much, so there you go. Cheese whiz. Yeah, cool. All right. Cheese whiz. What else? What else does a pancake have? I don't know, size maybe? Why not? What else? Yeah, like if someone makes me a pancake shaped like that, I'd be happy. Noted. Okay, what can a pancake do? What does flip do?
Reverses topping.
All right, this dot toppings equals this dot toppings dot reverse. Is that all I have to do? Yeah. But wait, does reverse the elements in line, or does it create a new array? You know what? Either way, probably this will work, hopefully. What else does a pancake do?
Satisfy.
Save that for later. Pancakes satisfy. Sure. What does that even do? Maybe it adds a new property. This dot happiness, that's how you spell it, equals true. Done. Okay, cool. Cool. Let's create a new pancake. Const pan1 equals new pancake. Whoops. Let's create a couple of them. Oh, I guess I'd have to return the pancake. Pancake. Okay. So, does everyone see what's going on here? Any questions? Creating an object, adding some properties to it, returning the object, just so it's really easy to create multiple on the fly like this. Yeah? Okay, let's make it a little bit more dynamic. Let's add in, or let's pass in some of the properties so that we can, like while using the function, we can specify its size and shape and things like that. Okay, so just in the function, I don't know, we'll specify its size, shape. Should we do toppings as well, or are the toppings always going to be like that? Maybe the toppings will always be like that. Did you know that you can do default values in? Yeah, good. Okay, so pancake.size, we're going to default to size. Pancake.shape, we're going to default to shape. Definitely got those the wrong way around, but that's fine. So by default, it will just have those sizes and shapes. Or I guess we could fix it and say it's like large and... I actually went to Michael's and saw cupcake molds in that shape. You make chocolate cakes. Yeah, right? I thought it was good. Okay, so we'll get I don't know, a small pancake that looks like Jesus, probably something you could sell on eBay. Okay, cool. 3 different pancakes. Yay! Let's console log them. Pan 1, pan 2, pan 3. Actually not sure what this will look like in Node. Pancakes. Wow, okay, there's a lot of pancakes. Right? You'll have the same toppings, but this one's a medium jazz hands, this one's a large poop, and this one's a small, looks like Jesus. A large poop. I mean, I think this is more impressive. Its size is literally jazz hands, and its shape spells out medium. Impressive pancakes. Okay, so any questions about this? No? Okay, so this kind of seems like a fine way of creating new objects. And like we define this once, and then I just get to call a function to create new instances of pancakes, which is great. Usually, when we create new objects, they will have their own bits of state that can vary. So our pancake size might be different each time. Our pancake shape might be different each time. Our pancake toppings might be different each time we create a new thing. So line 16, 17, and 18 might all have different versions of those properties, right? The state will probably change. Just like every person here probably has a different name, right? That's a state on us as humans. But the behavior, the flip and the satisfy, these are actually probably going to be exactly the same for every single pancake, right? Like maybe some would try and change it a little bit, but most likely these will be exactly the same. Just like you could tell any human to eat, or I guess flip or satisfy. Um, Right, behavior would probably be the same for each thing. But in this case, we are creating a brand new function every time we create a new pancake. So if I created 1,000 new pancakes, I'm defining 1,000 flip functions that are all identical. And 1,000 satisfy functions, which are all identical. Now, instead of creating all of these functions, 1,000 versions of them that are all identical, what if our pancakes didn't have those functions at all, and instead had another object that they could ask if they could use that function? Maybe you see where I'm going with this. Maybe the pancakes could have a prototype that has this function, so the prototype could be created just once. These functions will be created just once. We have 1,000 pancakes, and when we call .flip on them, they just check with their single prototype that they all share, and that might have the method or not. So how might I implement that? Make a new function? Do I need a new function? Make an object. What should I call the object? Proto pancake. Sounds awesome. What's going to go in this object? See, I'm going to keep writing it this way. I keep creating the object and now doing dot syntax. I'm doing this on purpose because it will tie into how constructor functions work. But this is exactly the same. You know, if I create the key value pairs here, or if I create the object, then do dot syntax, there's no difference. So I'm just going to move these two, right, pancakes to proto pancake. Okay, seems good enough. Now I need to be able to make sure that, I'm going to comment this out, but I need to be able to make sure that, like, let's do it with pan1, that I can flip and that I can satisfy, that it can satisfy me. That these lectures always get weird. I don't know why. The prototype lecture is always the weirdest one I do. So we have proto pancake that has these methods. We have our pancake that wants to use these methods. What will happen right now if I run my code? Flip is not a function. Type error flip is not a function. So what's the final thing I have to do? Make proto pancake prototype of pancake. Yeah. So if I'm going to break these up into logical steps. First, we create a brand new object. Then we apply state to that object. Then we set our object's prototype, pancake, to be proto, the proto pancake. And then we return that pancake. So we now have a function that's actually a really nice little function for us, creates a brand new object, sets all its state dynamically and differently for each instance, and then just sets the prototype to be proto pancake where all the behavior will exist. So all these methods will only ever get created just once. Now, should pancake be able to flip and satisfy? And is it okay that it even relies on the state of the pancake? Yeah, let's see. Well, I guess they did nothing because they did values, but yeah, that now runs. Let's actually console log pancake1 now. Ooh, here's a fun thing. Happiness does not exist on the pancake. I'm saying this dot happiness in the proto pancake and actually creating a value. I'm creating a brand new value that never existed until this point. Will happiness now exist on the individual pancake, or will it exist on our single proto pancake instance? So this still applies to the pancake that the method was called on? Yeah. So the this within the function will always apply to the thing to the left of the dot. Shouldn't say always apply. Will most of the time apply unless you use some bind or apply or, you know, those weird things. But by default, will apply to the thing to the left of the dot. So yeah, pancake1 now has happiness, and its toppings should be flipped, which they are. Yay. I'm curious though, does reverse work inline? Yeah, reverse does work inline, that sucks. Okay, so, any questions? This pattern right here is important to understand for today's assignments. Different syntax, but the pattern here, in that you have your empty object, you apply the state for each individual object, and then you just point its prototype to an object where all the behavior will exist. So behavior is created once, state can be created as many times as you need. Any questions? No? What I'm doing right here?
Yeah.
Only in the sense that you should use a constructor function instead of doing it, but this is how constructor functions work, so.
Well, it's got the, on the MDN, it's got the little, oh, that's the CI stuff you standardized.
Oh, you're talking about this?
Yeah.
Yeah, underscore underscore proto underscore underscore should not be used according to the documentation. If you were actually to alter prototypes, you should use different methods that do exactly the same thing as what I've been saying. So you would do, you could use object set prototype of, but that's also not considered. There's a lot of ways that JavaScript's like, hey, you can do it this way, but don't. The only way you should do it is object.create. If you're interested, I'll put this in the notes, in actually programming this way, which is a good way of programming. Object.create is way better than setting proto directly. But for the sake of a lecture, it's easier for me to just type proto, and it works, and that's fine. But yeah, for the curious, Google object.create, and you'll see how to actually program using object literals without constructor functions, without classes, in a really good, efficient way. Yeah. So let's take a 10-minute break. When we come back, we'll look at how constructor functions work. Okay, Calgary. Let me know when you're ready. So while we wait for Calgary, who has another good noun? Because let's create a brand new thing.
Building.
Buildings are fine.
Yeah, they're fine. That's the only way to find that.
Mine's okay.
I'm not up with it. They're not mixed. Is what you're talking
Do I look like I'm like I don't even know what that age is. 19 and younger.
You look fine.
I look fine, yeah. That's cool. The graduating cohort I was called normal looking, which is I thought was good. Yeah. No, apparently one of the students had like his computer open at home one weekend, and his girlfriend came along and like saw the mentors on duty or something. Was like, oh, that's a mentor, but he looks so normal. I guess she was expecting like devs to be hunched over. So I was called normal looking. I was like, cool, all right. Mama, boats. You know when you're ready.
Water bottle. Dragons. Dragons is good.
Shipping ships? Mentor. Right, yeah. So I guess she was expecting that, and then, saw, I guess, a normal-looking guy. So I was like, all right, I guess I'm normal-looking. As much say. Anyway. So, wait, what's the thing? We got shippy ships? Dragons? You know I'm not Joel, right? This isn't a Joel lecture.
No, this is entirely to do with us.
Hobbits? But I don't know what hobbits do.
We'll tell you.
I
They lose fingers.
I'm very hesitant to do hobbits, but I'm gonna go with it because it looks like. How do you spell hobbits?
Just hobbits with the F on there.
Hobbits. Hobbits.
Yeah. That's the end. Yeah, it's two B's in hobbits.
Now it's not.
It's not.
Hobbitses. 90s pop band. That would have been better. Just like you were a couple seconds too late. I blame the lag. Give it time. All right. Hobbitses. What do Hobbitses have? Let's play this game. All right. They have a home. What's the home?
Well, the Shire, obviously.
How do you Shire? Like. Yeah. Shire.
Sure.
What else? Hairiness. That's how you spell it. On a scale of 1 to 10.
Yeah, there might be a 8.
8 out of what? Who knows? It's just an 8 of hairiness. On a scale of 1 to 8, how hairy are you? Oh god. All right. This dot hovering. Hover is. How do you say that word?
Havering.
Havering. Oh, have ring. Have.
You'll have to cavalcade this, yeah.
Have ring.
And then it won't be a string.
Cool. Havering. What is that? Cool. All right. Sounds like it looks like everyone's into Hobbitses. Okay. This dot what?
This dot walking.
Walking
Yeah.
equals.
Are we on this actually yet? Or Daniel's function destroy ring.
That was a good one. But it's going to have to test to see if this dot have ring.
Okay. So if this dot have ring, then what?
And then this dot have ring equals that.
Equals. Well, wait, what then? What? You're going too fast for me. No, no, go on. This dot what? Fly you fools equals fly. Okay. Now what if they okay, what if they don't have the ring?
They have pretty walking. They garden.
They what?
They garden. This dot doing equals garden.
Wait, so if we tell them to destroy the ring and they don't have a ring, they
have to be walking.
Well, what would you do if I told you to
Like that's
destroy
what
a
the
ring?
okay, got it. All right. So let's do it this way. Let's guard. If they don't have ring, then you're like, hey, walking, duh, and then we return. However, if they do have the ring, so it's the rest. Yeah, there we go. It's a guard statement. Guarding is good. Cool. Everyone happy with that? So if they don't have a ring, then they're walking, and if they do, then they're throwing in the fire and some other stuff.
You can still walk with the ring.
But no, because they destroy it. So wait, what is walking?
Go on an adventure. They're all going on an adventure.
Oh, okay. Well, I'm gonna do adventure is like a 1, and if this dot adventure plus plus equals like 10, then this dot have ring equals true. Okay, boom. This got out of hand. How are we doing? Do we like what we see? I don't know. The logic could do with some unit tests, I think, to make sure it really works. But actually, let's make this a tiny bit faster. It's plus plus. Okay. Cool. Let's create some hobbitses. Oh wait, we should probably pass some stuff in. Okay, so let's have their home be passed in. And their hairiness. Hairy default is going to be 8. Have ring we'll have that be we can pass that in case we want to speed up the adventure, right? Sometimes you don't want to wait 3 movies. What? Okay, so let's create some stuff. Okay, yeah, cool. I have not mentioned what the hell's going on here, which is a good thing. We have a function. It's called hobbitses, and it has a capital H. Do we have functions with capital letters at the beginning? No classes. There are no classes. I already said that. Usually we do a lowercase letter. What happens if I use a capital letter at the beginning of a function name? It looks different, and that is it. Nothing more. There's no special behavior added to this function. It looks different, and that is all. And I want it to look different because I want it to be used differently, but that's it. It just looks different. Instead of, so when we created pancakes, I created a new empty object, and then I added all the properties to that object. In this case, I haven't created any new object. I'm just adding everything to this. Anyone tell me what's going on? Why am I just adding properties to this now? And what is this? If I call the function, what would this be? I mean, good point. Yeah, this is not nothing until I actually invoke this code. Jesus. Everyone knows more about hobbitses than I do. So, if I call this function like this, I'm doing it wrong. This is how I usually invoke a function, but that means this will be the global object, so global.home will be this, and it just won't work out that well. What I want a programmer to do is when they see this function, I want them to invoke it with the new operator. How do I tell them that I want them to invoke it with the new operator? I put a capital letter there. It doesn't change anything, it just tells other developers, hey, put a new operator to the left of this function. That's it. When I do this, when I create or invoke a function with the new operator, some special things happen. Okay, so let's create a new hobbit. What's our first hobbit's name? Frodo. Forod. My right hand was faster than my left. I couldn't. Okay, so we have Forod, and if I invoke a function, any function in JavaScript with the new operator, couple things happen. First, a brand new empty object is created, and it is set to this. So this equals a new empty object. That happens for us, which means that I can just start setting properties on it, right? Just like we did before, just like we did with the pancakes. Then, at the very end of the function, this gets returned. So it's doing this for us. We don't actually have to do this. So when I invoke this function with the new keyword, this turned into an empty object, we attach a whole bunch of stuff to this, then it returns this. So what is forod? Is a hobby, this is with a home Worcestershire, hairiness 8, havering false, adventure 1, and 2 functions, walking and destroy ring. Cool, and we can do this as many times as we want. So what's another hobbit? Bilob. Should we give Bilob a different home? Same home.
More
We can't just say that though. I have to copy and paste this now. That sucks. I should have. I can make home one of the final parameters. Now it's okay. Okay, so what's its hairiness? Like a 20? And does he have the ring?
Yeah.
Yeah. Okay. Sweet. Cool. Okay. So we got Bilob and we got Forod. The great thing about this is, like, if we were doing anything where licenses mattered, I don't think we'd have to get a license to do all of this. Right? Oh no, we're doing hobbitses with Forod and Bilob. I don't know what this Lord of the Rings thing is. Oh, see? Sometimes not being able to spell is a good thing. So here we go. We have our Forod and Bilob. Both live in Worcestershire. Different hairinesses, different havering values. Yeah, okay. So we can just create objects this way, just as we did with our pancakes. But there's a little bit more done here for us, right? And there's a little bit of convention going on here. JavaScript actually has this new operator built in, so we don't have to call our function new whatever. We name our function with a capital letter so that all developers know how to use it in the same way. And then we use this inside to actually assign state and behavior. So there's a lot of convention going on here. Any questions about this so far? Okay, so what is something kind of wrong with this? Something that we fixed in pancakes, but we haven't actually, like, what's the word? Identified yet in this code. Something not good about what we're doing here. Maybe like right here. Absolutely. When we create a new hobbitses, we are recreating this behavior, which isn't going to change for any hobbit. So, hobbitses. So we have this state for each hobbit, which can change. That's cool. We want that. We want state to be separate for each object, for each instance, and we want it to be able to change and be different. But this behavior is going to be the same each time, and we're just recreating these functions over and over again, which is unnecessary. It's a hit on our memory, but it's also bad because we could end up trying to modify the function in some way to act differently, and we might alter it for some hobbitses and not for others, and it could actually lead to code that doesn't work like we want it to. So how do we fix this? How did we fix it last time, and how do we fix it now? So we could put all of this behavior in a different object, and then what do we have to do? Yeah, so we attach all of this behavior to a different object and then make sure that that object is the new Hobbits' prototype, right? So, I don't know, what would that look like? Maybe we break this out just like before. I'm going to do it, up here. So instead of this, it's going to be, what should we call this new object? Hobbits' prototype. Prototype. We're going to set that to be an empty object. I guess I should scope it. So Hobbits is dot walking. Hobbits is prototype dot destroy ring, and then down here, right, we'll have to say this dot proto equals. Does that look about right? Did I get that right? Okay. So will I be able to? Oh, I can't even remember what this method's supposed to do. Okay, so let's try and ask Bilob if he can destroy the ring. Is that, yeah? There we go.
It's not canon, though.
It's not what?
It's not canon. Bilob doesn't destroy the ring.
Oh, the storyline doesn't work because Bilob isn't the one that destroys the ring. Like, you're like, wait, the prototypes, whatever, they make sense, that's fine, Sam, but this is madness. Okay. So what's going to happen if I ask Bilob to destroy the ring? It destroys him. What happens if I ask Forod to destroy the ring? This is. I should stop. This improv lecture style has gone out of hand. Okay, so that works. Yes, it didn't crash. We no longer see the methods attached to the Hobbitses, right? Here are the two of the objects. They have no methods. But we can still call the methods because it exists on the Hobbits' prototype, right? Hey, Forod, can you destroy the ring? No, I can't, but you could ask my prototype. I don't know, I'd watch that movie. Yeah, if Tolkien was a JavaScript developer, would have been a different story. I can't destroy the ring, but check with my prototype. Okay. Cool. All right, so that's cool. So that makes sense. Everyone happy with that? I'm going to do one thing. I'm just going to move this around a little bit. Okay. I'll put that here. Sweet. All right. So same code. But when we have our constructor function, we know that this will get constructed to an empty object when we invoke it with the new operator. We can then attach some state. We're then going to set the prototype and then add all the behavior to the prototype, and that way Bilob and Forod can ask the prototype to destroy the ring. Cool? Any questions? Does this all make sense? The JavaScript part of this. Does the JavaScript part of this make sense? Does prototypes, is this working? Constructor functions, all of that. Cool. So I'm going to drop something else on you right now. Every function in JavaScript, I got tangled. Every function, I'm going to write this down, why not? Actually, not every function, most functions. You know when you create a function with the function keyword? Yeah, those types of functions. So every function in JavaScript has, that's not a comma, has a property called, now this part I hate, .prototype. Every single function in JavaScript has a property called .prototype, which means two things. If you see a function, you know you can say .prototype on the end of it, and if you see .prototype on the end of something, it's a function. Okay, so this is not the function's prototype, but it is a property called .prototype, a badly named property. Let's just test this out really quick. Let's see, if I go into the node REPL and I create a function called thing.prototype. Boom, it exists on the function. What is the prototype? .prototype? What is that? Thing dot prototype. Whoops. Dot prototype is an object. Okay. Function has a property called prototype that is an empty object. Okay. Has anyone seen this dot prototype anywhere before? Has anyone seen something dot prototype at any point in MDN docs? Oh look, there's object dot prototype. Where else have we seen dot damn it. Dot prototype. Array, anything else? Right, like, you know, again, week 1 stuff, we were going to go like JavaScript map. Let's do map. Oh look, array.prototype.map. That's weird. So what do we know about dot prototype? What did I just say about dot prototype? What is the thing to the left of the dot prototype always? A function. Every function in JavaScript has a property called dot prototype. So, if you have a function, you can call dot prototype, and if you see dot prototype, the thing to the left of it is a function. So, what is array? What is capital A array if it has a dot prototype property? What did I just say it is? Everyone together. A function. Well, let's see. Array is a function. What else did I say has a dot prototype? Oh, object. Like type of. Capital O object has a property called dot prototype. What is type of capital O object? It's a function. Anything that has a dot prototype is a function, unless someone actually manually goes in and sets a property to be dot prototype, but that would be unfortunate. Yeah.
Is that not just syntactic wrapping? Everything in JavaScript is an object.
Okay, so
Because you can do
not everything in JavaScript is an object,
well, other than the primitives
other than the primitives.
and the symbols.
Yeah, so a function is a type of object, but it's a special object. So, you know, it would be fair to say that all functions are objects, but not all objects are functions. So if you see that object is a function, that's like, oh, it's an object, but it's also a function, which is special. Does that kind of answer what you were thinking about, or what?
Kind of, but it's the reason why it returns type of function is...
The reason it returns type of function is because object is a function. I can only use that parenthesis syntax with functions. Object is a function. Array is a function.
So functions are objects.
Functions are objects, also, but objects are not functions.
No.
Not all of them, no. So object is a function, array is a function, and anything else that has a dot prototype is a function. All functions have this dot prototype thing. What is this dot prototype thing? It's a what? It's not a method. It's an empty object at the beginning anyway. Property on all functions called dot prototype that starts out its life as an empty object. So like object.prototype is an object. Array.prototype is an object. In that case it is.
You said that using the new
Yes.
gives us a free object.
Using new gives us, you know, a free object. So yeah, it does this for us, yeah. Does it have anything to do with prototype? Exactly. Does it have anything to do with prototype? So three main things happen when we use the new operator with a function. So if I say new hobbitses, first of all, a new empty object is created, and this is that new empty object. So we assign all the state. The second thing is that this dot proto, or this is prototype, is set to the function's dot prototype. So the function starts out its life, every function starts out its life with a .prototype property that is an empty object. And then this is done for us, which is kind of nice. Because look, we did the exact same thing. We set this .proto to be an empty object. But that's already done for us. This .proto is already an empty object. Cool, all right, and if we use the new operator, this is already done for us, so I don't need to do this. Whoops. And I don't need this. So where do I attach all of this behavior? If I'm taking it away from Hobbits' prototype, exactly. Exactly the same thing that we just did, except we're utilizing the default behavior of JavaScript, and that when we invoke a function with the new operator, these steps are already done for us. The exact same code, the exact same logic, there's just more done for us behind the scenes. So now, in my constructor function, I'm going to assign all state to this, which is going to be our new object, and then I'm going to assign all behavior to the function's .prototype, which is the new object's prototype. The naming, I think, is one of the worst parts here, the fact that it's called .prototype. But all the concepts are still the same, so everything should work exactly the same, except we're not doing any extra work. We're not creating any new extra objects. So node hobbitses, there we go. Still works the exact same way. And the reason it's done this way is, well, we've already gone over it. We want to attach all the state to every single instance of the object, but behavior is going to be shared between all of the objects. So we might have 1,000 hobbitses, that all have a different hairiness or adventure level, but they're all going to have the same walking and destroy ring method. We might create 1,000 different arrays that all have different values in them, but they're all going to use the exact same map method. So we're going to attach that to array.prototype. Map exists just once, and then every array, when we ask the array to map, it's going to say, well, I can't map, but here I'm just going to ask my prototype. And that's how that works. Any questions? So when you see constructor functions working or used, this is how they're done. You just create a function, assign a bunch of state to this, assign a bunch of behavior to the function's prototype, .prototype, sorry, and then you just create new instances using the new operator. Now, if you were to look at just these lines, what does that look like? Kind of looks a little bit similar to how classes work, right? Started out the lecture by saying that there are no classes in JavaScript. I will reaffirm that. There are no classes in JavaScript. There are no classes in JavaScript. So if I create a class and I call it French fry, what is French fry? Yeah, what is French fry? Let's console log the type of French fry. Anyone got, I heard one person say it's a function. Any other guesses? It's an object, maybe? Undefined because classes don't exist? Does someone just want to completely, be like, damn it, Sam, classes do exist, it's a class. No? All right, let's see. Looking at the last line here, it's a function. Yeah. In fact, it's a constructor function. In fact, I can do all the same things I was doing up here, but on this class thing. Every time I attach a method in here, let's see. What method would we want French fries to have? Fry, cool. Right, this is my class syntax. Maybe it console logs ouch, because that would hurt. This method doesn't exist on an instance of French fry. It exists on frenchfry.prototype, because that's how constructor functions work. So actually, instead of console logging that, I could say frenchfry.prototype.fry. And my point here is not to try and confuse you or for you to memorize this syntax. It's to show you, look, it's a function, it has .prototype, I can call .fry on it, which is kind of what we've been doing up here. But if this works, which it does, right, classes are nothing more than a very light, thin, confusing wrapper around constructor functions, which are a big, annoying, confusing wrapper around object literals, which are actually really simple. So simple we teach them on week 1, day 3. But yeah, ever since classes were introduced in ES6, they seem to be the default go-to when people want to use like this new operator. Like, oh, let's just use classes, which is just this wrapper around constructor functions, which is what everyone from object-oriented languages used to try and make it feel like JavaScript was an object-oriented language with classes, which it's not. So you will see a ton of code that uses constructor functions. A ton of code, like everything written in JavaScript from the beginning of JavaScript until a couple of years ago, written by developers from other languages, has constructor functions. Because developers would come from C++ or C# or any other object-oriented language and be like, oh, I want JavaScript to work the exact same way as those languages. So constructor functions. Really what developers should do is come to a language and use a language as it should be used, not try and push their ways on it. But JavaScript kind of like grew and evolved from these developers, and it's you kind of end up with a bunch of weird stuff, but I think you already know that JavaScript has a bunch of weird stuff, so I don't need to explain that. Unless you want to just spend the rest of the time talking about how JavaScript is weird. I could do it. I could do a whole lecture on how JavaScript is weird. It's bumping on your sweater. Sorry. That was only a couple minutes ago, so it's only been painfully loud on their end for a little while. So, any questions? Any questions? Nothing? Yo. So what's the difference between like class here and like class in a real language, a language that has real classes? The behavior is going to end up being different, and you're going to get different things. So it depends on the language completely, and it's kind of a difficult question to answer. But a lot of the times you could think of classes as being this blueprint. So classes are nothing more than instructions on how to build objects. They're not objects, they're just instructions on how to build the object. So you have a class, well, that's great, I have a blueprint, let's like build a building out of it. Oh, now I have a building, now I can do things. And that's generally how it happens. You have the blueprint, you create instances of the objects from the blueprint. In JavaScript though, it's just objects linked to other objects. So it's not like I'm creating an object based on this object. It's like, well, here's an object, I'm an object, but I'm gonna like, you're gonna be my prototype, so I'm gonna ask you for help if I need it. So classes usually imply this kind of like blueprint or kind of copy behavior. Like I'm going to create a copy of everything in this new instance of what I'm doing. Some languages, like C++, allow for multiple inheritance. So you can actually have multiple blueprints and create an instance from that. So yeah, it just kind of works a little bit differently. If you were doing basic JavaScript development, really basic stuff, and you weren't getting too into it and you didn't ever run into any bugs or issues, you could pretend that this class is like every other class. It's when things go wrong or when you're getting a little bit more than just like a basic developer that you should understand actually what's going on, what happens underneath the hood, why .prototype appears everywhere, what is going on there. It's better to understand how the language actually works. So at a basic level, you can kind of pretend classes are classes, but really like when you start asking questions like, well, why can't I have private things in a JavaScript class? Which you probably wouldn't ask unless you came from another language that had classes. You'll understand now, well, it's because objects in JavaScript don't have anything that's private, and classes aren't actually anything other than functions that create new objects that, yeah. Also, in most other languages that have classes, you have to create objects from classes. So in Ruby, on Monday, you will see that you cannot create anything unless it's from a class. In JavaScript, I can just create a new object on the fly. That's fine. I just create, object with object literal syntax. JavaScript is really unique in that sense. Most other languages, you first have to have your class, and then you have to create an instance of the class always. So that's something that you'll see is quite different next week. I think, was that a good enough rant? Yeah, cool. Made enough sense. I haven't touched on extends here. With constructor functions, one of the assignments goes over that, and you'll see that you can achieve the exact same behavior. For people really interested, if you get done with the work today, you should try doing everything just using object literals and object.create. That'd be a fun exercise. Otherwise, I don't know. Any more questions? Anything else anyone wants to see gone over, or anything weird? We could talk about like how do you detect if something's -0? That's a fun one.
Because classes are like new, is it sort of like best practices to avoid using them in like deploying code or in the workplace, or?
So because classes are new, should you avoid using them? That is never a good thing to do. Because X is new, should I avoid using it? No, never. Classes in this case, like, yeah, it depends on what everyone else coding on your project is doing. So if everyone on your project wants to use classes, cool, use classes. If everyone wants to use constructor functions, use constructor functions. If everyone just wants to do object literals, cool. If you want to try never using objects and you only create functions and use primitive types, fine. Just make sure you're consistent. I would hate to go to a project and see classes mixed with constructor functions and object literals. That would be awful. But like, you used React last week. When React first came out, you were supposed to use, I think, constructor functions for everything. And then about a year ago, maybe longer, they changed all the documentation and said, actually, you know what? We want everyone programming using the React library to actually use classes. And that's why all last week or this week you use classes. But that means like if you're looking at any of your React code, I should see classes and probably not, too much mixing. Does that kind of answer your question? Yeah, so use whatever you want. How do you think a static method works with a constructor function? What is a static method? It's where... Okay, so if I had a static method, what would a static method be? What would a static method of French fry be? Sure, why not? Well, no, let's do something that actually kind of makes a bit more sense. French fry... That'd be an instance, though. What would... See, class methods don't even make sense to me. Like, when would you use them? No, because it would be all instance stuff. Honestly, class methods, static methods are most of the time useless. Try to avoid using them, or overusing them anyway. Let's just make a random thing. What has nothing to do with French fries? Superman. Cool. What does that mean? It means that I can now... Let's just have something actually happen there. It means that now I can say French fry.superman, right? It now exists on the class. Okay, that's how static methods work on a class. If I have a constructor function called hobbitses, whoops, how would I attach a function to the function hobbitses? Just add it. Absolutely, there's your static method. No, but static methods never do. No, that's it. Because it exists on the function itself, not on the prototype. Remember, if we wanted it to all the instances of new objects, we would say hobbitses.prototype. But yeah, so it's like, that's another thing too. There's nothing special going on in JavaScript. It's really good to understand that. 'Cause you're like, oh, I want these static methods. What are static methods? They're just methods that exist on other functions. It's like, it's more simple than it's made out to be. Whoops, 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 whoops. I think it's way more simple. Like, it's object literal simple. As long as you can understand that objects just talk to other objects and they have this kind of like this prototype association, that's it. That's all that's going on. All the rest of it's just noise. Yeah.
Jeremy said that we could achieve a type of privacy using closures.
Yes. You can achieve a type of privacy using closures. All right, hold up. You pasted a link, and then someone else said, okay, hold up. When should we seal/freeze our objects after using a constructor? I'm just going to pay attention to Calgary for a moment. What do you mean? When should we seal/freeze our objects after using a constructor? Alex, what do you mean? By also seal and freeze, are you talking about using a library like freeze.js or something? Also, why might you opt for a static method rather than... Yeah, good question, Adam. Why would you opt for a static method? I don't know. Maybe? I don't know. I mean, I'll try visualizing that. Ooh, this is cool. Object.seal. When was this? How long has this been available? Once you scroll down, it's been available since like day 1 of JavaScript. ECMAScript. Oh. It's 5.1, so it's ES6. Okay, so it looks like an ES6 thing. Object.seal method seals an object, preventing new properties from being added to it, marking all existing properties as non-configurable. Values of present properties can still be changed as long as they are writable. It depends. Ideally, seal would just be probably default. That's a tough question to answer, but I would say you'd seal an object if you really want nothing more to be added, so you don't want to take advantage of duck punching. Object.freeze, freeze an object, froze an object, no longer be changed. Okay, now this is more interesting. This is great. If you freeze an object, if you were to create an object from a construct function or anything else, you just create it, you give it all its state, and then you freeze it, you never ever change it, your code is going to be way more, or much less likely to have unexpected side effects. If you have a value in your code somewhere, and it can just change from underneath you, which all objects can, all arrays can, everything can, except for primitive types, then you lead to code where you expect one thing to happen, but actually the values were changed in some way, so something else happened. If you can freeze an object, if you can actually make sure that nothing else happens to it, then you know that your code is going to be safe. You don't get any unexpected side effects. You pass an object to a function, it shouldn't modify that function, so by freezing it, you're making sure it absolutely can't happen. It's like how when you use map, it's really safe because you pass it an array and it gives you back a new array. That's what freezing would be good for. As for seal, I don't see a great use case, but freezing, yeah, freezing sounds great. Again, is this an ES6 thing? Let's just see. Yeah. Oh, no, 5.1. Oh, it's just definition. Yeah, so these are newer things, but really cool things. By default, it would be nice if objects just got sealed when you use const. Some languages do it that way, some don't. They're still asking questions. You said something about making stuff private through closures. I'd have to think for a minute about how I'd go about doing that. I guess. No, I don't think it would be truly. All right, I'd have to. Maybe let's do that as a assistance request. Because the way I'm thinking still wouldn't be truly private. Seal might be useful when you're writing a library. You don't want other people to screw around with it. Yeah, that kind of defeats the purpose of like writing code for people to be able to use, though. Maybe. I don't know, a lot of these features, like seal and freeze, is like protecting developers against developers. It's just like, don't be a bad developer. Yeah, but you know what I mean? It's like how much restriction do you put on like the code making sure the developer programs well before you're just like, you know what, maybe we should just like teach the developers how to program well. Yeah, again, I think that's like developers should just program in a good way rather than relying on language features like that. Yeah, anyway. Wow, we are really 3 questions here. Any other questions? Fun things. Are you sure you don't want me to show you how you can determine if a value is -0? Are you sure, though? We got one person that's sure they don't want me to show them how to figure out if something is -0. Okay, cool. Then I'll let everyone. Yeah, you can. You are adjourned. Anyone interested in determining if a value is -0? You know where to find me.
Afternoon.
What? Afternoon?
Well, we're not supposed to make a systems request.
I didn't say systems request. I said you know where to find me. For that though, we should get Jeremy because I want to know what he. I guess I could Google it. The private thing.
Is he in?
He should be in today, I think. I think at noonish. At noonish.